Algebra 1, Lesson 73, Factoring the Difference of Two Squares and Probability Without Replacement. So, let's start with factoring the difference of two squares. What they mean by that are two perfectly squared numbers, for example, that are being subtracted. So difference, subtraction, and then two squares. For example, x squared, perfectly squared number, and 4, perfectly squared number. Now, in order to factor these are going to factor just like our trinomials into two sets of parentheses. But you see, it's only a binomial, or it's two squared numbers instead of our typical 3, where the x1 term in the middle is missing. First, I'll show you the rule to factoring them, and then we'll explain why it works through checking our answer. So the checking your answer step is not required. All that's required is the rule to solving them. The rule is very simple. You take the positive term. The positive term will always be your lead term, and you find the square root of that. That becomes your first term. Your signs will always be positive, negative. So one will always be positive, one will always be negative. No rules we have to remember about signs here. And then the last term will always be the square of your second number. So what's the square root of 4? Well, that's 2. And I'm done. Ta-da. So positive goes first. Signs are always different. Square root of the last number. Very easy to factor the difference of two squares. Now, the question is why, and that's where checking our answer comes in. So if we were to take this polynomial and FOIL it, the first times the first would give me x squared. The outside times the outside would give me negative 2x. The inside times the inside would give me positive 2x. And then the last times the last gives me negative 4. Now, what we notice is when we go to combine like terms, negative 2x plus 2x cancel each other out. And then all we're left with is x squared minus 4, which is what we started with, which means that we did our answer correctly. So that's why difference of two squares works. If you have two perfectly squared numbers, the factorization causes the middle term to get canceled out. So let's go ahead and do a couple more difficult examples. All right, starting off with this top one here. We have negative a squared plus 49m squared. So we're going to put this into two sets of parentheses. And if you remember the first rule I said for difference of two squares, the positive number always goes first. Now, what's the square root of 49m squared? Well, square root of 49 is 7, and then square root of m squared is m. So this first term actually has two numbers, 7m. And that's okay, that's allowed, 7m. Now, the signs will always be positive, negative. And then we go to the negative term next, and what's the square root of a squared? Just a. And that's our answer. That easy. It's great. So once we know the rules, very easy, and then a little bit of understanding helps us solidify why it works. And remember, always, always, always start with the positive term first. A lot of times they'll try to trick you by putting the negative term first. Now, let's go to the next problem. We've got 25y squared minus 36a squared. Starting with the positive number first. Square root of 25 is 5. Square root of y squared is y. So first term is going to be 5y. Positive, negative, like always. And then the last term, or the negative term, square root of 36 is 6. Square root of a squared is a. And I'm done. That easy, that simple. That's it for difference of two squares. Now let's talk about probability without replacement. The way probability without replacement works is the parameters of the probability change. The way they explain this is by drawing marbles out of a jar. So we'll go ahead and we'll do this practice problem D. They tell us an urn contains 4 purple marbles and 3 pink marbles. 2 marbles are drawn at random. What is the probability that both marbles are purple if the marbles are drawn? 1 with replacement, 2 without replacement. What they mean by with replacement is after the first draw, if I take a purple marble, I drop that purple marble back into the bin before I draw the second time. Without replacement means after that first draw, I keep that purple marble and it does not go back in, which means the parameters have changed. So let's think about this. We have a jar. Inside of this jar, we have 1, 2, 3, 4 purple marbles, and in standing for pink, we have 3 red marbles or 3 pink marbles. Now, in the probability with replacement, again, we're drawing 2 times, so I've got 2 options. I'm going to multiply both of those 2 options by each other. Now, on the first draw, how many favorable outcomes are there for me to grab a purple marble? That would be 4. Now, how many total possibilities are there? It's not 3, it's 7. 1, 2, 3, 4, 5, 6, 7 marbles total. So 4 out of 7 for me to draw a marble. Now, if I drop that marble back in, the exact same odds repeat. So I then have 4 out of 7 chance again. So that's going to give me a 16 out of 49 chance with replacement. Now, let's talk about without replacement. Again, 2 options. First option, going to be the same. 4 options out of 7. Now, what changes is after this first draw, if I do grab a purple marble out of this jar, it's now gone. And I don't drop it back in. So what changes is how many favorable outcomes there are and the total number of outcomes. So since I've taken 1 purple marble out, I now have 3 desired outcomes and a total of 6 possibilities. So I multiply 4 over 7 times 3 over 6, which gives me 12 over, what's 7 times 6? 42. That will reduce to, what, 4 over 7. That reduces, or no, sorry, 4 over 14. No. What's going on here? 2, wait, hold on. I'm having trouble with math today. 6 goes into 12, 2 times, 6 goes into 42, 7 times, 2 sevenths. There we go. So it reduces to 2 sevenths. I should have cross multiplied, or cross canceled. This could have been 2, this could have been 3, and then those would have canceled. Man, I could have made life so much easier for myself. All right, but that's probability without replacement. And your final answer would have been 2 sevenths there. If you have any questions, let me know on Moodle. I will see you in class.